Hello students, today we are going to teach you culinary fruit sculpting and make one of these cute little animals.
Ah, seems like there's a power outage. So much for the generators.
Dang it, well, I guess I'll go try to fix the wires or something.
Nah, I got a better idea. Wait a minute.
What is all that?
Well, let's see. We got some lemons, we got some vinegar, some alligator clips I took from Doc, some decorative copper sheets, and nails. I think these were for the bunny eyes. We got some sandpaper and some LEDs I took from the cabinet.
So, I don't get it. How are we going to show the students how to make citrus sculptures? We don't have any light.
Well, we're going to use our lemons to make a lemon battery.
I was going to use those lemons for the bunny heads, but I guess this works too. Wait, how are we supposed to make a battery out of a lemon and a couple nails?
Let's get into our lab safety gear.
Safety first. In this case, we have a piece of fruit with citric acid, so we need to wear goggles and gloves to protect against the acidic splash. And definitely don't eat any of the fruit after use. And be careful with the sharp nails.
To build our lemon battery, you'll need a few simple materials that you can either find at home or at the hardware store.
Here, we are using lemons, copper strips, galvanized nails, double-sided alligator clips, multimeter test leads, a couple pieces of sandpaper, and some 2 to 3 volt LEDs.
First, you're going to need about 3 to 4 lemons. Pick ones that aren't too bright yellow. Why? Because ripe lemons won't have as much of that great fleshy juice. Gently roll them on a table to release the juice inside, just like I'm doing here.
Next, to ensure the best connection, sand down 1 whole zinc nail and 1 copper strip for every lemon to help improve the reaction, just like this.
Now that we have the lemons with the acidic lemon juice ready to go, grab a paper towel and cut them in half. Insert 1 zinc nail and 1 copper strip on opposite sides of the lemon.
After all the lemons are set up, just like this, connect them in a chain using the double-sided alligator clips. You're going to connect 1 alligator clip to the zinc nail on 1 lemon to another lemon's copper strip, so the electricity can travel through the system.
At the end, leave 1 zinc nail free and also 1 copper strip free, meaning don't have them connected.
These will each connect to the multimeter test leads. Depending on your voltage of your LED, you may need more or less lemons. Each lemon makes just under 1 volt of electricity. Connect your test leads with the alligator clips to the zinc and copper. The red lead equals positive, and you're going to connect that one to the copper, while the black lead equals negative, and you're going to connect that to the zinc nail.
In our lemon battery, we have two elements. They are the metals copper and zinc. Here they are next to each other on the periodic table. In our experiment, the copper comes from our copper strip and the zinc comes from the galvanized nail. Now you may ask, what does galvanized mean? It just means that the nail is coated with the element zinc all around. Zinc and copper each act differently with electrons, and that's important for a lemon battery to turn the LED on. The lemon juice helps keep the charge flowing. Zinc and copper each interact differently with electrons, and that difference is what powers our lemon battery and lights the LED. The lemon juice helps keep the electric charge flowing between the two metals. Think of it like a sports play. Zinc is like the quarterback ready to throw the football because it easily gives up electrons. Copper is like the wide receiver ready to catch or receive those electrons. The alligator clips connect the zinc to the copper, and those then connect to the LED, creating a path for electrons to flow. And the lemon juice, when the lemon, helps balance the charges inside the lemon so the flow of electrons continue to power the light. So for our non-sports folks, and to keep it really simple, the zinc on the nail really wants to lose electrons, so it gives them up pretty easily. The copper is the opposite. It really wants to collect those electrons. But those electrons cannot move unless there's something that lets the charge flow, and in that case, that's the lemon juice. Once everything is connected, a chemical reaction happens. Electrons start moving from the zinc to the copper, and that movement of electrons is the very definition of electricity. Unfortunately, a couple lemon batteries aren't going to be able to keep the lights on if the power goes out. The average light bulb in the US takes about 120 volts to be powered, which means you would need about 140 lemon batteries just to power one average light bulb. With the average household containing about 50 light bulbs, you would need almost 7,000 lemon batteries just to keep the lights on.
That's a lot of lemons. What else can we try to use to keep the lights on?
Well, another alternative to lemons is using vinegar as the conductor. Remember, a conductor is needed so that the electrons can flow between the two metals, copper and zinc. Alright, that's enough chemistry. Let's get back to the experiment.
First, pour some vinegar into 3 paper or plastic cups.
Next, place 1 copper strip and 1 zinc nail into each of the vinegar cups. Make sure they do not touch each other.
Then, connect an alligator clip from a copper strip in one of the cups to a zinc nail in a different cup, just like we did with the lemons. Connect the alligator clips from cup to cup, and in the end, it'll look something like this.
Then, connect your test leads to the open copper strip and zinc nail.
The red lead goes to the longer leg of the LED, and the black lead goes to the shorter leg. If the LED lights up, that means electricity is flowing through the circuit.
This vinegar battery works very similarly to the lemon battery. The acid in the vinegar reacts with the zinc, causing some of the zinc atoms to dissolve and release electrons. The electrons then flow through the vinegar toward the copper.
The copper helps collect the electrons on the other side. Meanwhile, the vinegar acts as an electrolyte, and just like the lemon, it allows the charged particles inside the solution to move and complete the circuit so the reaction can continue.
You know, Eddie, as I look around our kitchen lab, I'm seeing many alternatives and other materials you can use instead of vinegar or lemons. We've got salt, which you can mix with water. We've got Gatorade. We've got limes and oranges, and you can even use this white cooking wine.
You could even use Taco Bell hot sauce or Dr. Pepper.
Wait, I'm drinking that Dr. Pepper. That's not an option.
Bottom line, class, all of these different items around your kitchen can all be used as the electrolyte instead of the lemon or vinegar.
Eddie's right. have fun with picking out some version of a lemon. The key is to find a liquid or item where there are electrolytes. Some may work better than others, but just experiment. Test different variations of the experiment, like substituting oranges for lemons or Gatorade for vinegar, to see which electrolyte works the best.
Wow, so that light is really just being created by a couple pieces of metal and a lemon or vinegar?
Yup, the chemistry in the reaction of the zinc and the acid can cause a small flow of electricity. This experiment can help us understand some of the ways that power is produced in the real world through chemistry. For example, burning of fossil fuels like coal is through chemistry, a process called combustion, which is one of the main sources of power we use today. And the best part is, we can see again. We don't even need the power when we have lemons.
Ryan, I don't think that small light helps very much.
Oh, seems like the power is back.
Oh, so we don't need to use these lemons anymore?
Nope, we're all done with those.
So, you want any lemonade? It's shockingly good.